Okay, we are going to be recording this session. If anybody has any objections with recording, please say so now. Okay, thank you. So what we're talking about now is the relational model, okay? Just to give a very quick recap of what we saw last class before we see one of the examples. The relational model comes about through some work that C.F. Codd did around the 1970s. And it's basically a model that helps us describe a system, in this case, a data system. And it has a direct link with the ER model that we had already worked on. And basically, it's a way to represent the data structures in a way in which we can directly implement it into a database system. It's also the basis for the structured query language, which is one that is a standard that's used in database management systems. It's also the basis for almost most modern commercial database management systems. And it's based on a uniform data structure where we've got the data organized in tables. And basically, we already spoke about this. The table isn't anything other than either an entity or a relationship that's represented with a certain structure. And the tables have columns. These columns are going to be basically what we have been calling up to this point the attributes of an entity. It takes as a basis the ER diagram and also the cardinality of the relationships between the entities that we had previously I'm sorry, that we had identified in the ER diagram. It also uses normalization. Now, normalization is a topic that we haven't addressed yet. That's the next topic that we're gonna see after we finish up this one. And so important concepts in the relational model. A relation is going to be a table. It's also called a file. And it's going to contain the data that we're storing. The relation or the table or file is going to have the data organized in rows. And each row is referenced to columns that represent characteristics that are important of this data. The columns, as we mentioned before, are actually the attributes of the entity or relationship. And a record or a row in this table is going to represent a set of data that's related to each of these attributes or contains a set of attributes. Now, a database is going to be composed of many tables that are linked somehow. That are linked, and we've got an example here. The database is in symbology. It's usually represented like that, a kind of tub that we've got there. And so in this tub or container, we've got 3 tables, and the tables are going to be linked. Now, in the relational model, a column is going to represent certain characteristics of the entity or the relationship. And remember that these characteristics we called attributes. So columns in a table are also called fields, and they're called attributes. And they're going to be these characteristics that we have for the table and the entity or relationship. And we need to really think about, we did this, we mentioned this when we were talking about definition of attributes. We needed to remember that we need to select these attributes, these characteristics carefully to really have the ones we need for representing data into the system. So the ones we need are going to be there, and we need to think about this. So for example, we've got an ID card that has a series of fields here. These fields are going to represent the attributes. So this is an ID card for an employee. We've got the name of the employee, first name, family name, nationality, salary, date of birth, marital status, the shifts, where the ID card was issued, and the sort of expiration or until when it is valid. And then we've got the data itself, which is the values we have for each of these fields for a specific case, for Isabel Whelan, who is British and earns a lot of, I don't know if that's euros, dollars, or pesos, but if that is a monthly salary, it's big. Any or either way. Now, in the concepts that we're also going to be talking about, we talk about a domain. What is a domain? In math, we defined the domain of a function, and I'm going to go to Giselle's definition that she told us last class, and it's basically the possible values that are valid for that function. Same thing's going to happen here. The domain is going to be the set of data that's going to be valid for a particular field or column or attribute. So for example, if we've got a field that's marital status, well, there's certain marital status that's going to be valid for that field: married, single, divorced, separated. A shift, assuming that a shift is an attribute, a field, or a column, the shift is going to be, assuming that it's the weekdays, then it's going to be from Monday to Friday: Monday, Tuesday, Wednesday, Thursday, Friday. The domain of the salary, we're going to assume that's going to be positive numbers from 0 up to a maximum value. A negative salary wouldn't make sense. And the names are basically going to be a set of characters. This is where it gets interesting, because if we just leave it open-ended as a set of characters, we can actually have anything there. So the domain are going to be these acceptable values for the attributes. Now, the records are going to be the content that we have in each of the that we're going to have in the table, according to specific values for the columns that are going to be related, and these are going to store data. So the records are going to be the rows that we're going to have that contain data that is related to each of the fields. So for example, in this table that we see here, which is a table of publishing information for a book, for books, we've got 4 attributes or columns: record ID, publication date, author, and title. And we've got 4 records. The records are also called rows, and they're also called tuples that contain the information, the data. Each of the columns is going to have data in it that has characteristics. So for example, record ID is going to be a number. Publication date is going to be, the data type is going to be date. Author field is going to be text, and title field is also going to be text. This is important because data is going to have data types. Okay, so the data types are going to be, remember programming, that you have to have different data types. So there's going to be numbers, they can be integer, floating, a date, a text. These are going to be the characteristics of the type of data we're going to store in each of the fields of a record. And this is important because in the database, in the end, we want to extract information from records, from the database, and that's going to be done through records, and the fields and the data types are going to help us do queries. So for example, I can request a selection of records through a query where I say, give me all of the books that have been published before a given date, or after a given date, or between 2 given dates. And that's going to help us structure a query that is going to help me extract records or rows or data from the tables in the database. Now, another important concept is the degree. A degree is going to be the number of attributes or columns that we have in the table. So in the previous example, it was 4. So there's several terms here that are, let's say, equivalent. Okay. The first column here, the formal terms that we have is relation, tuple, and attribute. That's in the COD model. A relation is also called a table. It's also called a file. A tuple is also called a row or a record, and an attribute is also called a column or a field. The most formal way, according to the COD relational model, is the first column, with talking about relations, tuples, and attributes. The most commonly used in database terminology is the second column, where I'm sorry, we talk about tables, rows, and columns. Now, for example, in this example that we've got here, we've got a table that has information of employees. So what are the elements that we have here in this table? Well, it's a table where we've got five attributes, which is emp ID, emp name, emp initial, emp first name, and emp job code. These five attributes, these are the five attributes or columns or fields of our table. And this table has 1, 2, 3, 4 records. It has 4 rows. It has 4 rows, 4 records, or 4 tuples that have the data, the specific data. The possible domain for the fields are going to be given from with regards to the data types and information that we store there. So for example, emp job code, we've got 12, 18, 15, 18. That means that there are certain ranges that we can have there. And we kind of note that it's 2 digits and goes from maybe 12 to 18. We don't see any more information there. Employee ID is 6 numbers that start with 1, 2, 3, and have 1, 2, 3, 4, 5, and then go with a consecutive number. So that's kind of the possible domains given by these possible values. Now, how do we create the relational model? We are going to define a table for each of the entities that we have. We're going to assign a name for each of the tables, for each of the entities. It's probably going to be the same name we define for the entities. And the attributes of the entity are going to be the columns of the table, or the fields in the table. And then we look at the relationship or cardinality. A table has to have a distinct name. There should be no duplicate rows or records. That's important. And the entries in each of the columns are what we call atomic. That means they can't be divided. They have to have the same domain, the entries. So if I have a column or an attribute that has information stored as a data type for a date, then I have to write a structure for a date. I can't write text there or anything else. And these are some examples of data types there. We can only do operations with data types of the same type. So I can do operations with integers, for example, but I shouldn't do operations between integers and text, or integers and date types. Each attribute or field has to have a distinct name. The sequence of the columns in a table, they don't matter. We can put them however we want, and also the sequence of the rows. When we order information or sort it, that's when we extract the information. But once we put information into a table or define the columns in a table, they can be ordered however we want. They don't have a specific order. When we're naming attributes, we're going to be using small words that represent or describe things, and these are called mnemonics. A recommendation is to not have these attributes be very long, and we have to have it's recommended to have a certain nomenclature or structure that can help us to easily identify what it means, or what the attribute means. So example, we have the table, a table that has a student, or the table student. Then we've got the student ID. We're going to call that STID, the name STNM, the phone STTEL. So we're starting with ST, that means student, underscore, and then the specific characteristics of the attribute. And you notice that there's a structure there for naming the attributes. Same thing with the table employee. We've got employee ID, emp ID, name, emp NM, phone, emp tel. So emp tells us, that mnemonic tells us that it's an employee, underscore the specific attribute. These are examples of how we can structure the names for attributes, giving them a sort of homogeneous structure, and that's what's recommended. And lastly, cardinality. With regards to cardinality, there are going to be certain rules that we're going to follow. And remember the weak entities and all that didn't have primary keys? Well, this kind of sorts that out. Based upon the cardinality, if we have two entities that have a cardinality of 1-to-1, then basically we're not going to have to create two tables. We're just going to make one table, and we're going to add the primary key of table 1 into the new table as a primary key also. So if we have any relationship that's 1-to-1, we don't need two tables. We can fuse that into one table. If there is a cardinality that's 1-to-n, then basically we're going to add the primary key of the entity that's 1. We're going to add it to the entity or the table of the entity that has the n cardinality. And if we have a cardinality that's many-to-many, in that case, where there's many instances related to many instances of two entities, we're going to create a new table. And that new table is going to have both primary keys from the two original entities. These are kind of the rules we're going to follow. And that's why defining the cardinality was important, because it's going to help us with the structure. Now, let us revisit the Sosa Corp example. So we know that Sosa Corp is a global company that does something. It does it very well. And it does it to please and generate value to its stakeholders. We had mentioned that the company was organized in departments. It has employees. Employees work on departments. Employees can also work on projects, and departments manage projects. And employees can manage a department. And employees also had dependents. And these were defined for insurance purposes. We had identified the entities. We had identified 5 entities: employee, department, project, and dependent. And we had also defined the relationships. Employees were assigned to departments, employees managed departments, employee supervises an employee, employee works on projects, employee has dependents, and department manages a project. We had identified the cardinality for each of these relationships. And this is a summary of the cardinality. Employees and departments had an n-to-1 or 1-to-n. Employees and departments as management relationship had a 1-to-1. Employees and other employees were supervised, had a 1-to-n. Employee working on projects were many-to-many. Employee and dependents were 1-to-n, and department and projects 1-to-n. And we had identified dependents as a weak entity because we didn't have a primary key there. We had established attributes for each of these. Employee had social security number, name, address, salary, gender, birth date, status, manager start date. Department had an ID and a name. Project had an ID and a name. And dependent had name, gender, and relationship. Notice that we had defined the attributes, but we hadn't defined a structure for naming each of the attributes. That's something we need to do. We had identified the primary keys as the social security number for employee, the department ID for department, the project ID for project, and we noticed that the dependent didn't have a primary key. So it was a weak entity. And lastly, we had done the ER diagram. And in the ER diagram, we had identified each of the entities, assigned the relationship and the cardinality. Okay, so in the ER diagram, we have all of the entities, we have all of the relationships and the cardinality. Now, in this step, we need 2 more steps to be able to take this and grab a database development software and be able to implement. The first thing is that we need to extract from the ER diagram and all of the previous information. We need to get the we need to get the relational model, and that's getting the tables that we're going to implement. And the next thing we need to do, and we haven't seen that topic yet, is normalization of those tables. But first, let's do the relational model, which is extracting the tables here. So what did we just say about the tables? How many entities do we have here? We've got 1, 2, 3, 4 entities, right? We've got these 4 entities: employee, department, project, and dependent. Well, that means we're going to have 4 tables, at least 1 for each entity. Do we have any relationships that are 1-to-1? Well, yes, we do. We've got employee and department. So that means that somehow I have to include the information of one and the other to be joined into one table. Do we have any relationships that are one to n? Yes, we do. We have a few of them. For the relationships that are one to n, I'm going to include the primary key of the one entity into the n entity. And lastly, do we have any relationships that are many to many? Yes, we've got employees and projects are many to many. In that situation, I'm going to create a new table. Okay, so let's see how that would look. First of all, I've got the 4 tables for each of the entities: employee, department, project, and dependent. Those are the 4 original entities that I had. And I've got the attributes for each defined here. And I've underscored and put in bold the primary keys that we had already established for each of these 4 entities. Now, there is a one-to-one relationship between table and department. I'm sorry, between employee and department. Okay. Remember that we have a one-to-one relationship with regards to employee managing a department. So what have we done there is that I've added the department table into the employee table. Notice that I've copied the department table and department information is here, okay? And I've linked the primary keys of one to the other one. The rest of the relationships that we have are one to n. Employee and department, employee and supervising employee, employee and dependents, and department and project, okay? And so for those relationships, what I've done is that for each of the tables, I've added the primary key of the other table, of the n table, the primary key has been added. So for example, employee department manages many projects. So what have I done? I've added the department ID, the primary key of department, to the project table. An employee can have many dependents. What's happened here? I've added the primary key of employee into the dependent table. And notice this. Suddenly the dependent has, I've added an ID to make it not be a weak entity. Department has many employees. The department ID of department has been added to the employee as a primary key. And lastly, we have a many-to-many relationship. That is, employee works on projects. There's many employees can work on many projects, and projects can have many employees. That's a many-to-many relationship. When I have a many-to-many relationship, I create a new table that's called employee project that combines the primary keys of each of the tables that comprise it. So the project ID and the employee social security number are combined here in this new table. And I add any additional attributes or columns that I consider necessary. Lastly, we describe the attributes. And so we have created a structure here for naming the attributes. So for example, what we're doing is using a mnemonic at the beginning that describes the table. So the table emp, table project PRJ, table department dept, and table dependent dep. Table employee project is the combination. And then we have other mnemonics added that describe the specific attributes. So we have emp underscore SSN is the social security number, emp underscore name is employee name, emp underscore name project underscore name, PRJ underscore name is project name, dept underscore ID is department ID. And so now the attributes that we had originally defined, we're giving them a nomenclature. And it's a standardized nomenclature for identifying them. And we're giving it a brief description, okay? This is the relational model that we're gonna be able to take and we're gonna be able to implement in a database management system, okay? we're going to be able to implement it in a database development system. I'm sorry. So actually, when we open Microsoft Access and start to do our database, we are literally going to create 5 tables with these attributes that we have given here. And we're actually going to be able to create this diagram and link up the information, define the primary keys. And that's the way we're going to create the database. This model, which is the relational model, is going to help us directly be able to implement it into the database development system. However, there's one thing that we haven't done, and that's normalization. That's going to be the next topic. And normalization is nothing else than a procedure we're going to follow to validate that our tables to validate that our tables are structured in a way that we're not going to create any sort of that we're going to reduce as much as possible the possibility of having any of the anomalies that we have talked about, the insertion, deletion, and updating anomalies. And that's going to be a process that we're going to see when we talk about normalization. Okay. So this is basically, if you notice, everything that we did starts from the analysis part, and from the analysis, we get the information that we need to be able to identify entities, identify relationships, identify cardinality, identify attributes and primary keys, do the ER diagram. And from the ER diagram, it's relatively simple. We just create tables from each of the entities, validate the cardinality, and in the cardinality, the only thing we're doing is, if it's a one-to-one cardinality, I'm going to put one entity into the other, or one table absorbs the other. If it's 1 to n, I just need to verify that the primary key of the 1 is included in the primary key of the n. And if it's a many-to-many relationship, I'm going to create a new table that's going to have that data, and define a certain structure for the for naming the attributes. And this is going to kind of round out the design part of the design part of our stages for the development and deployment of a database system. Next, after this, after we do normalization, we're going to be able to directly implement this. And that's the development stage, where we actually put the database into a structure, into a software that's going to be able to, where we're going to be able to create interfaces, we're going to be able to create queries, and we're going to add functionality so the database actually works and does what we need it to do. Okay, so this kind of rounds out this this topic that has to do with the relational model.